All right, this is lesson 5.3, day 1, and kind of like a lot of our lessons, we're going to take this over 2 days. And I've underlined this a little bit already, but let me just hit it again. We'll learn a couple new identities today, and it's going to be a sum identity and a difference identity for cosine. If you're looking ahead, I wonder what chapter 5, section 4 is going to be about. Well, if this is cosine, you think that might be about sine, and you are right. And if you kind of get this down for 5.3 with the cosines, then the sine part is going to flow very, very nicely. Okay, first question is, why learn an identity for sum, so sum is addition, or difference, which is subtraction for cosine? Why don't we just take the cosine of A plus B? Wouldn't that be the cosine of A plus the cosine of B? And why do we need an identity? And so let's try the cosine of 45. You remember what that is from your chart from way back in the first chapter? So the cosine of 45 is square root of 2 over 2. What's the cosine of 45? The square root of 2 over 2. What happens when you add up the square root of 2 over 2 plus the square root of 2 over 2? You get the square root of 2. You get 2 square root of 2 over 2, which is square root of 2. Is that the same thing as the cosine of 90? How much is the cosine of 90? Wait, the cosine of 90 is 0. So can you just take the cosine of 45, and add those up and get the cosine of 90? And the answer is no. It doesn't work that way. Too bad that it doesn't. But it just doesn't work that way. And you can try some other ones, the cosine of 30 plus the cosine of 30 or anything else in your chart. And it just doesn't work to take one, add it to the next. So does it equal 45 and 45? Does it equal 90? And the answer is no, absolutely not. It doesn't work that way. Instead, it involves a little bit of a complicated identity. And it's not an identity we're going to derive, but it's an identity we're going to learn how to use. So it turns out if you're adding up two angles, the cosine of A plus B, you get a little more complicated identity, and the book proves it, and I can certainly prove it to you later. It turns out it's the cosine of A times the cosine of B, and then you get this weird other factor minus the sine of A times the sine of B. So if you want to add up two angles, it's not just a simple matter of taking one plus the other one. It's a matter of taking the cosine times the cosine of the first times the cosine of the second minus the sine of the first times the sine of the second. And the same thing when you're subtracting, it's cosine, cosine. And look, the sine is always the opposite. So plus sine, sine. Okay? Why would you want to use these? Well, before calculators, they would help you because all you have in your chart is a 30, 45, and 60. It'll give you angles in between, like a 15 or a 75 or 105 or something like that. And so you want to use it for that. But now with a calculator, why would you still want to know these identities? And the answer is it comes up in calculus. So if you take more mathematics, you are going to see these identities come up, and your professor is going to say, hey, does anybody know the cosine addition identity? And if you raise your hand, that will be incredibly impressive. Okay, I want to show you a couple examples where we try these, and it's going to depend, like I said, back on chapter 1, if you remember that chart, and I'll remind you what that chart is. But if you remember that chart, and if you've got these new identities down, I think you're going to find this very straightforward. All right, so let's try one of these. Oops, did I skip one? Let's try the cosine of 75 degrees. And again, you think immediately to your chart, and we had x or theta, and let's get the cosine. And in our chart, we had a 0 and a 30 and a 45 and a 60 and a 90. Remember that chart? And actually, I should make the chart a little more extensive. It shouldn't just be the cosine. It should be the sine and the cosine. And again, just to remind you how you construct that chart. Remember, the sine was an increasing function. It was 0. It was 1/2. Square root of 2 over 2. Square root of 3 over 2. And 1. And then the cosine was the exact opposite. So it goes 1. Square root of 3. Sorry, that's sloppy. That's the square root of 3 over 2. Square root of 2 over 2. 1/2. And 0. You might remember there's a tangent in there too. We don't need the tangent, but we need to know that much of the chart. Okay, question today is, what's the cosine of 75? And you look over here at your chart and say, I don't have a 75. I've got 90, 60, 45, 30, and 0. Those are the only ones I know. But when you look at those, you realize, wait a minute, 75, isn't that 30 plus 45. So you come back over in here and say, I know the cosine of 75. It's the cosine, in parentheses, of 30 plus 45. All right, the answer to the next question is no. Can I take the cosine of 30 plus 45? Would that just equal the cosine of 30 plus the cosine of 45? Would it just equal that? And the answer, I told you already, it is no. It doesn't work that easily. Too bad it doesn't, because you could have just taken this value and added them up and been done. It doesn't work that nicely for cosines. They don't add up like that. So instead, we have to come back to our cosine identity. And we look back here and say, wait a minute. What happens when I add up two cosines? I use this formula right here. So let's use that formula. How did it go? It went cosine of A, cosine of B, and when there's a plus, we put minus sine of A, sine of B. So in our case, it's the cosine of 30, cosine of 45, minus sine of 30, sine of 45. And trig is nice because you certainly use trigonometry, but you review all these other things, which are so good as you're going on to college. So cosine of 30, you'll see here in a second. Cosine of 30, square root of 3 over 2. Cosine of 45, square root of 2 over 2. Oh, look at fractions. We have to multiply. Minus sine of 30, 1/2. And the sine of 45, square root of 2 over 2. Okay, how do you multiply fractions? Well, you multiply the tops. So it looks like I get the square root of 6. Multiply the bottoms over 4. Here I multiply the tops. Looks like I get the square root of 2 over 4. And since I have a common denominator, my final answer is going to be the square root of 6 minus the square root of 2, the whole thing over 4. And that would be the value of the cosine of 75 degrees. So not simply a matter of adding up just two values, it's a matter of using this new formula. So cosine, cosine, minus sine, sine. Okay, that's the main idea. I'll show you a couple more variations on it, but really that's the idea. If you got that, you've got the idea. All right, let's try it again. Cosine of 15. Let's duplicate that chart. I should have been smart and copy and pasted that over here. But it doesn't hurt to write it again. What do we know? 0, 30, 45, 60, and 90. That's degrees. Let's do our sine first. Our cosine second. Sine, remember, is an increasing function. In the first quadrant, that is. Cosine is a decreasing function. So we've got that chart. Okay, now I'd like to know the cosine of 15. Well, I certainly don't see 15, but I see a couple of ways to get 15, and you can take your pick here. Either one will work. Couldn't we do 45 minus 30? Or couldn't we do 60 minus 45? So let's choose one of those two. And it doesn't make much of a difference here. So let's go with 60 minus 45. And you can try 45 minus 30 at home. It's going to be the same thing. Okay. Is it going to work, or it's just the cosine of 45 when it's the cosine of 60? No, that does not work. We need our identity with the subtraction in here. So let's take a look at that again. Look, it's the second identity, which goes cosine, cosine, plus sine, sine. So I've got the cosine of 45, I'm sorry, cosine of 60 minus the cosine of 45. The identity tells me it's the cosine of A, cosine of B, always the opposite sign, so a minus inside the parenthesis gives me a plus here. So cosine, cosine, plus sine, sine. And again, maybe that step you're doing in your head. So I've got the cosine of 60, cosine of 45, plus the sine of 60, sine of 45. Is it really that easy of just reading these off the chart? It is. Good review, but not that bad. Cosine of 60, look. It's a half. Maybe you don't need the chart. Maybe you have these memorized. 45, square root of 2 over 2. Sine of 60, square root of 3 over 2. Cosine of 45, square root of 2 over 2. How do you multiply fractions? Multiply the tops. So it looks like a square root of 2. Here I've got square root of 6. and the whole thing over 4. Looks a lot like the previous answer. Not quite the same, but similar. Plus square root of 2 plus square root of 6 all over 4. Okay, that is the main idea. Just a couple more problems that go with this to show you. What if instead of degrees, we switch to radians? Well, if I had that problem, I think the first thing I would do is I would get rid of the radians and go back to degrees. And again, how many degrees is pi? Pi is 180 degrees. So I can take out the pi and put in 180. 180 divided by 12. Oh, look at that, it's 15. But guys, we've got a negative inside here. Do you remember in section 1 of chapter 5, we talked about negatives inside a cosine? And it turns out inside a cosine, the negative doesn't matter. So the cosine of negative 15 is the same as the cosine of 15, at which case you say, wait, I already did that question. The cosine of 15 was question number 2. Look, we had just done that one. So you can go through the whole problem again if you like, or you can say, wait, I've done it. I've got the answer. I remember what it was. It was root 2 plus root 6 all over 4. But I need that identity to get it, so it's not a matter of just taking 45 minus 30. I've got to go through that whole identity again, had I not just done it in the previous problem. Okay, a couple more things to show you, but you've got the main idea. Do you know your identity backwards? Look, guys, they gave us cosine A, cosine B minus sine A, sine B. That's the right side of the identity. Come back here and take a look at that. That's this side. Sorry, I've written on this so much. That's this side over here. Cosine, cosine minus sine, sine. Make sure was there a minus there? Yeah, cosine, cosine minus sine, sine. So what does the right side, I'm sorry, what does the left side look like? That was the cosine of A plus B. But wait a minute. I know what A is. I know what B is. So it's the cosine of 25 plus 65. You always do order of operations. You do the parenthesis first. 25 plus 65 is 90. And I know the cosine of 90 degrees. You should know it too. The cosine of 90 degrees is a big 0. So here's one where they gave us the identity backwards. We had cosine, cosine minus sine, sine. We said, wait a minute. That's right here. So these identities work frontwards or backwards. All right, and the very last one today, a true-false question for you. 2 true-false questions. What do you think? Cosine of 41 plus cosine of 13? 41 plus 13, would that equal 54? I hope you're saying false. That's why we have these complicated identities, because cosines don't just add nicely like that. We need an identity, and so they do not just add up like that. So that would be false. And now let's take a look at this one. Cosine, cosine minus sine, sine. That looks like an identity. Oops, not sine. Wouldn't that be the cosine? And wouldn't that be the cosine of 64 plus 26? But wait a minute. How much is 64 plus 26? 90. But wait a minute. What's the cosine of 90? That's 0. And that's exactly what they said it was going to be. So our second identity, no calculator needed for something like that. Our second identity is true. So that's the first part. That's actually the main part. There's a couple of trickier problems that'll come later. But that's the main part of Chapter 5, Section 3. Chapter 5, Section 4 is going to be very, very similar. So if you can get this down now, it will make Section 4 much easier as well. So those are identities. You can start practicing those, and we'll certainly practice those tomorrow in class as well. That's it for the lesson.